Hi, my name is Craig Orr. I'm leading the marketing product planning function here in the US for Samsung Foundry. So these days, everyone in the industry is talking about heterogeneous integration in one way or another. This used to be reserved for high-end GPUs or CPUs or ASICs, but now we're seeing it across literally every segment. So today I'm going to talk about the growing importance of heterogeneous computing and how the integration of all these technologies at a system level is becoming at least as important, if not more important, than any individual technology you choose. I'll also help you think through about how do you make some of the design choices that are inherent to the heterogeneous integration. But first I'll talk about how Samsung Foundry fits into the overall Samsung equation. So Samsung Foundry itself is part of Samsung Electronics. Samsung Electronics is split up into a division that makes kind of end products and a separate division that makes semiconductors. In any given year, we're either number one or number two semiconductor in the world by revenue. And Foundry is a very big part of that and a growing part of it. And it's an independent business unit within the Device Solutions division. So Samsung Foundry was established as a business line for very few customers and very few applications way back in 2005, and it stayed that way for a long time. But we've realized that we want to make this a very big part of our Vision 2030, which is to become the leading memory and logic company in the world. We've committed $100 billion to make that vision happen, and Samsung Foundry is a big part of that vision. So what we're doing right now is we're trying to build on our heritage of really strong expertise in mobile and consumer and expand first into higher performance applications and eventually into the full suite of applications and customers that a true general foundry serves. We're very much well on our way to achieving this goal. So if you did an internet search, just type in Samsung Foundry in the past couple of weeks, you'll have a few results that come out that kind of demonstrate our progress in this regard. So one of the results will be from Hot Chips, where IBM and other data centers companies highlighted the chips that we're doing with them. IBM specifically mentioned their Power 10 CPU. NVIDIA also did a press release and an event and a website that shows that Samsung's process was one of the enablers for the biggest generational improvement they've had in their GPUs. So I encourage you to go search those links from our partners and see the amazing things that they're doing. There's also a lot of things that are not yet announced by our partners, and we're not going to announce those today either. But I think we're safe to say we're making pretty good progress on this journey as we go to become a very large and leading general foundry. So I mentioned the performance segment and our expansion there. A lot of people ask me, what is performance segment? And the answer is very simple. It's anything that's big physically in terms of die size or fast in terms of clock frequency. So that includes CPU on client and server side, GPU on client and server side, and then pretty much everything that would be inside a data center, whether that's hyperscaler or enterprise. We've put together a platform to address this performance segment. And this platform includes pretty much everything you would need to do a chip at these advanced nodes. You can think of it as a set of Lego blocks you can put together in different combinations to make your chip. In a very purposeful way, we pulled these solutions together to make it really easy for you to go in and design these advanced chips, especially heterogeneous chips, from both a technology perspective, an infrastructure perspective, and a business model perspective. We have very flexible solutions which help address some of the complexities that we're seeing today with heterogeneous computing. So why do we need a platform? The answer is simple. It's complexity. So Moore's Law, as many visionaries, including Hennessy and Patterson, Jim Keller, Raja Kaduri at their recent talks that are all over the internet now, have brought this up as well. So we don't need to expand too much, but the basic point is Moore's Law is still alive. It's going very strong, but it does need that little bit of extra boost to help make it even better than it ever was. The way that boost is being achieved in the industry now is largely through heterogeneity. Heterogeneity in terms of a chip architecture adds a lot of complexity. So you have all these different pieces you have to bring together, the SerDes, the packaging substrate, the interposers, the thermal management, the design flows, the embedded passives, how do you set up your supply chain, all of these things. There's so many choices and so much complexity. And then once you actually get all of that stuff together and working, how do you do the after sales service? You know, if something goes wrong, whose fault is it? Everyone's kind of pointing at each other like this. So this is why we created this platform, to make the design choices easier and to make seamless integration that enables really successful bring up of these heterogeneous platforms. So you might ask, okay, so that explains why a platform is needed. So now the question is why Samsung's platform is interesting. So the traditional ecosystem for the semiconductor industry is very much divided into areas of specialty with these partners all working together. And Samsung is a very big part of that ecosystem, very big supporter of that ecosystem. And we continue to offer that ecosystem. But what we also bring to the table is this unique capability of having literally every step of the supply chain in-house if we choose to, which is everything from design services. You know, we design chips for our customers, not for ourselves. We have a large team that develops the process flows, proven process flows for the various degrees of integration. We also have, of course, the required teams for the DK, PDK development for all the design collaterals, as well as in-house IP teams for select IPs when needed. And that's all in addition to the manufacturing strength, which is our core business, which is the fabrication of wafers and, you know, the packaging to go with that. So having all of these things in-house really gives us this unique perspective on the challenges of the industry and allows us to pull things together to create really system-level solutions. So we bring the integration, the technology, and then the scale to manufacturing it. And that really results in a faster time to market for our customers, better PPA on the solutions that do come out, and a lower risk supply chain. So first, let me talk about kind of the core pillar of what we do, which is process technology. We have process technology that are optimized for every price and performance point. It's a matter of choosing what's right for your application by considering maturity, PPA, and cost. So if you're doing an application, let's say, for example, you know, storage applications or chipset applications that require, you know, relatively lowest cost but still a good performance, then you'd want to go with our 14 nanometer node. If you're doing something on the cutting edge, like a CPU or AI training or, you know, GPU, etc., you might want to consider our EUV nodes. We have a really strong heritage in EUV. We were the first to bring EUV to market. 5 nanometer, what you see there is our third EUV node that's ramping to production. And then 4 nanometer there is our successor that's coming out right now. And if you wanted something between those two extremes, you'd have this PPA per dollar story with our 8 nanometer node, which is really an excellent trade-off. But between going all the way to EUV and sticking with the mature nodes. So it's very well proven, but it also has a really good PPA. We also have a full set of IPs that help you realize all those applications that you see here on the screen. But one of the key IPs that I want to highlight is our portfolio of high-speed SerDes. And this shows a subset of that. But what I want to talk you through is what we have available there and how you might consider making the different choices between the various types of SerDes. So we have basically support for the full breadth of reaches and speeds and signaling types within the SerDes domain. Those can be either serial or parallel or standard or proprietary, depending on what your design goals are. And they come primarily from our design partners, but we also have some available in-house in certain cases if that would be necessary. So as you think about choosing a SerDes, you know, it can be very daunting with all the different channel characteristics, different distances, et cetera, that you have to bring in into your choice. On the top of this slide, you can see the OIF IEEE definitions of SerDes. And this kind of tells you what the naming convention is based on the distance and channel characteristics of that SerDes. But on the bottom, I want to talk you through a simplified version of how you make some of those choices between the various options that are out there. So if you can, to put it very simply, if you control both ends of the wire, you may want to actually go with a proprietary SerDes because you can achieve better PPA. than a standard SerDes might be able to. And then if you are considering shoreline to be more important, then a serial solution that's proprietary might be better for you, while if you consider bandwidth, total bandwidth to be more important, then a parallel option might be better suited to your needs. If on the other hand, you control only one end of the wire, then a standardized solution might be something that's more in line with what you're looking for. On the right-hand side of this chart, we can talk about how to choose between, especially LR type interconnects between chips. Here, I think the decision largely comes down to what you're going to be connecting to. So if you're connecting to your own ASIC, the world is your oyster. You can choose LR SerDes, proprietary SerDes, something PCIe based like C6 or CXL. Whereas you're connecting to x86, and you're going to want to probably stick with some PCIe physical layer that supports CXL. And if you're connecting to another chip, then basically it's going to depend on what's on the other end. And that'll be case-by-case decision. So hopefully that helps clear up some of the challenges of the complexities around choosing a SerDes. Part and parcel to the heterogeneous choice that you have here is also what kind of packaging is going to go, which kind of packaging is going to be with your solution. And that's really a big part of also choosing your SerDes as well. So like we have a full solution portfolio for SerDes, we also have the same thing in packaging from both us and from our partners, whether that's 2.5D or flip chip BGA. And then we have our 3D that's available from Samsung, as that is a front-end technology. As you think about choosing a packaging technology for your heterogeneous system, you really have to weigh performance and cost versus the size are the key kind of two dimensions. And if you think about the very top left of this chart, you have X-Cube, which is our 3D technology. Samsung has the only proven 3D technology in the industry. We've been manufacturing for many years. So this will get you the highest performance at the lowest latency and lowest power per bit. On the opposite end of the spectrum, if you want to do something very, very large and you were willing to trade off performance to get a better cost point, you can do multi-chip module. And then in the middle, we offer a whole bunch of alternatives. So if you wanted something, if you're more cost sensitive and can live with a smaller size and a little bit higher wide spacing, then you can go with our R-Cube, which is an RDL interposer. If you wanted to take a step up from that, we have COS variant, a chip on substrate variant of our iCube silicon interposer, which offers great performance but at a lower cost, but is relatively smaller size. And if you want to go all the way up in terms of performance on 2.5D interposers, you can go do something as sexy and attractive as our COW that you see in the picture there, which is 2 logic dies with 8 HBM. That's our test vehicle there. So we have really a full portfolio of technologies, and we also have a technology called integrated stack capacitor that's really critical to delivering the power for all these different kinds of packages. So let me talk to you a little bit about that. So this ISC, as we call it, integrated stack capacitor, helps solve a few of the challenges that are emerging as you go to higher power, higher performance, and heterogeneous chips, which namely are really high power density and power total die power. So if you look at some of the chips that are being designed today, they're starting to increase in power and eventually will be kilowatt range type solutions. They're also moving to heterogeneity, which is the topic of this talk. And as you do that, you have power noise coupling that gets more severe. And both of those things basically drive a need to have a more advanced power delivery network. So I just pulled a random picture off the internet here. You can see this graphics card there. A huge percentage of the board is actually used for the power delivery network. The electrolytic capacitors, tantalum capacitors, and the inductors take up most of the space on the board, actually. So as I mentioned earlier, we're solving these problems at a system level. So if you want to bring all these different technologies together and make a system that overcomes a lot of the challenges that we just talked about, this ISC is a key component to that. So basically you can take this, integrate it as a WOW, wafer on top of your logic as a discrete component or in your interposer, and it'll help you bring down your impedance and improve your high frequency response such that you can operate at lower threshold voltages or at higher voltages if you want to maximize your performance. So it's really an enabler of optimized solutions in terms of power and performance for these large heterogeneous chips. And it's something that we think is critical to enabling these 1 kilowatt type packages going forward. So as I wrap up here, I want to leave you with one final thought. Just think about what you can do with all of the technologies that Samsung has to offer. If you combine the various types of packaging, the various SerDes we have, and the design solutions, the manufacturing, you could actually build a chip like this, something that's integrates 3D stacking technologies to increase the number of cores and the amount of throughput you get per watt. You could supplement that with additional dies that are integrated by 2.5D integration they could also be different 3D stacks themselves, or they could be monolithic chiplets connected with high-speed SerDes. You could, in addition, take a bunch of HBMs and put them on that same chip, and this would really be combining all the most advanced technologies in the world that can all be done in one place. So I encourage you to think through the implications of this and how you could leverage that in your designs, and I hope this talk was helpful for you. So a lot of what I've talked about today was really about the increasing importance of integration in this heterogeneous world. What I also want to stress is that that's not the only thing that matters. In addition to creating these system level solutions, we're really driving as hard as ever, if not harder, at making the traditional scaling improvements, making things better, faster, cheaper at the basic technology level. That's not changing. And ARM is actually a big part of that. So we work very closely with ARM on a lot of things. We have ARM standard cells and memory compilers, as well as GPIO on at least 8 of our process nodes that I'm aware of. We also have a large selection of ARM's POP IPs, the performance optimized IPs for their cores on a variety of our process nodes, especially at the advanced nodes. And we have IPs that cover the full spectrum of applications, whether that's automotive, IoT, infrastructure, or higher performance applications, as well as mobile and consumer, of course. So ARM has been a great partner with us, and we continue to leverage that partnership to help try and bring the best solutions to the market at the individual technology level, as well as at the overall system solution level. Finally, I'd like to leave you with an invitation to join us at our own event on October 28th, where we'll discuss more details of our roadmap and technology. So please feel free to go to that link there. So thank you very much for your time.